All right, chapter 1.4, perimeter and area in the coordinate plane. Essential question, how can you find the perimeter and area of a polygon in the coordinate plane? What you will learn in this chapter section is how to classify polygons, and you will find perimeters and areas of polygons in the coordinate plane. So let's get right to it. Okay, we begin this chapter section with a core concept, polygons. In geometry, a figure that lies in a plane is called a plane figure. Recall that a polygon is a closed plane figure formed by 3 or more line segments called sides. Okay, so we can't have less than 3. 2 sides that would not close. 3 sides is a triangle. 4 sides is a quadrilateral, and so on. Each side intersects exactly 2 sides. So let me explain that with pens here. So if I chose the side AB right here, that side right there intersects exactly 2 sides. Well, it's intersecting side BC and it's intersecting side AE. Every side intersects 2 others at a point called the vertex. So they're labeling D the vertex D. So side AB would intersect side AE at vertex A, and it would intersect side BC at vertex B. So that no 2 sides with a common vertex are collinear. Okay, so no 2 sides with a common vertex are collinear. What that means is let me do it really straight on this one. If AE went from here to here, and then you said, okay, well now ED is here, that can't happen. That's collinear. That'd all be on the same line. If D were right here, that would be on the same line. And so let me do that. If I put a dot there, D, then that whole side AD could be called a side. So there's no point on a side that breaks a side that's straight into 2 pieces, as you can look at it that way. There is no point here, and this is not a side, and that's not a side. We just don't do that. So they are not collinear. Okay, so that's what they mean by that. You can name a polygon by listing the vertices in consecutive order. Okay, so in this polygon, it's A, B, C, D, E. You could name it D, E, A, B, C, but generally speaking, we usually do it in alphabetical order, or we start at one point and go around in a clockwise fashion. Okay, so in this case, we would call it A, B, C, D, E. And there are 1, 2, 3, 4, 5 sides on this. That is called a pentagon. Okay, example 1 says to simply classify. It says classifying polygons, and it wants us to classify each polygon by the number of sides. Let's highlight this. Classify each polygon by the number of sides. Tell whether it is convex or concave. Okay, and I'll get to that in a moment. So first of all, this one here has 1, 2, 3, 4 sides. So it has 4 sides. So a 4-sided figure is called a quadrilateral. Okay. Okay, now I'm going to do B. I'm going to classify it first. So first of all, I count 1, 2, 3, 4, 5, 6 sides. So I'm going to write 6 sides. And that is called a hexagon. Okay, so now let's talk about classifying them as being convex or concave. A polygon is convex if you extend its sides, all of its sides, infinitely, and they never go through the interior of the polygon. So example, if I drew a line and let's make it red. And I drew a line right here. And it went forever and ever and ever. It's never going through the center. If I drew another line here for this side, it goes on forever in both directions. It's never going to into the interior of the polygon. This side here can go on forever both directions, never going inside. And this one here as well, just like that. And this one here, and this one here. None of the sides ever go within to the interior of this polygon. So therefore it is a convex polygon. So I'll write that now. That is convex. Now, if I do the same over on part A, let me go back to my line and arrows at both ends and that. And let me see, let's do this one in blue. So if I draw this line, sure, great, it never went through the interior. But if I move that line now to say this side here, make that a little thinner too. Okay, as you can see, when I extended this side here, it cut through the center of this polygon. It went right through the interior of the polygon. That will classify it as being concave. The other way you could think of is the sides caved in. The angle pushes in, the vertex is greater than 180 degrees on the interior. Okay. So that is a quadrilateral, concave, hexagon, convex. Okay, example 2, finding perimeter. Okay. Perimeter in the coordinate plane. Okay, so it says find the perimeter of triangle ABC with these 3 vertices. So we're trying to find the perimeter. Hopefully you remember what perimeter is from prior math classes. Perimeter is distance around an object. So think of it as putting a fence around an area. The length of all the sides of the fence would total the perimeter. So the first thing I would do to do this problem is to graph it. It's not necessary to graph it, but I'm going to do that to show you the shape it creates. Obviously, we have 3 vertices. 3 vertices would create 3 sides. So this is a triangle. And we're going to put one point A at -2, 3. And I'm going to do this in Desmos. So A is going to be in -2, 3. So if I type in -2, 3, enter, and label it A. Okay, so there's A. And then the other one is B is 3, -3. So 3, -3. Label B. And then lastly, C is -2, -3. Okay, so now if I were to connect these sides, you would see it's a triangle. Okay, so finding the perimeter with these 3 coordinates, I've actually learned today how to do line segments in Desmos. So over here, I'll explain one of them. So x equals -2 is this vertical line right here, this purple line. If I just type in x equals -2, it's going to go on forever off the screen both directions. But then if I use brackets and say to restrict the range of that line segment from 3 to -3, then it cuts it off at those points. So here is my triangle. And let me zoom in so we have, there we go, that's better. So now I can tell if I start here, that's -2, that's 1, 2, 3, 4, 5. So BC has a length of 5. 1, 2, 3, 4, 5, 6. AC has a length of 6. So 6 plus 5 is 11. I could then do the Pythagorean theorem to find AB. So I'm going to do it this way, but then I'm going to show you the distance formula way as well. Okay, so BC was 5 just by looking at the graph, and AC was 6. So if I go back here, then I can say the length of BC equals 5. The length of AC equals 6. All I need now is the length of AB. Okay, let me make sure I'm doing this right. I'm looking for AB. BC's 5, AC is 6. BC's 5, AC 6. I'm looking for AB. So AB, I would do the Pythagorean theorem. The Pythagorean theorem is A squared plus B squared equals C squared. So one of my legs is 5. The other leg is 6. And AC is my hypotenuse. 5 squared is 25. 6 squared is 36. And that equals C squared. So 25 plus 36, 6 plus 5 is 11, 3 plus 2 is 5, plus that carried 1 is 6. So C squared equals 61, and then I take the square root of both sides. The square root of C squared is C, and I get the square root of 61. Now it was, and the real actual answer would be plus or minus the square root of 61, but we're dealing with distance here, and distance cannot be negative, so we want the principal root. Principal root means only the positive root. So the third side is the square root of 61. So if I write that square root of 61, I believe 61 is prime. 2 won't go in. 6 plus 1 is 7. 3 won't go. 5 won't go. 61's prime. So if I find the perimeter of this, the perimeter is AB, the length of AB, plus the length of BC, plus the length of AC. And AB was the square root of 61. And BC is 5. And AC is 6. So 6 plus 5 is 11, plus the square root of 61. Okay, this question did not ask you to approximate or anything, but I'm going to. We don't usually leave an answer like this, 11 plus the square root of 61. What I would do is go back to Desmos and just put the square root of 61 in the calculator and see what its value is. So the square root of 61 is approximately 7.81. So if I go back now and I change this to 7.81, then 11 plus 7.81 is 18.81. So the perimeter is approximately, because I rounded, 18.81 units. I should actually write that, and I will. Units. Okay, that's one way to do it. Now, if I were not to graph that, then I would want to find the length of AB. And what we do here is we do the distance formula, which is difference in y squared plus difference in x squared, and take the square root. So we'll write the formula, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Substitute in the givens. So I'm doing AB right now, so that's these. So x sub 2 is 3. X sub 1 is negative 2, minus a negative is plus, be careful with that. Y sub 2 is negative 3. Y sub 1 is 3. So this is going to give me 5 squared plus negative 6 squared. Simplifying that, we get 25 plus 36. And 25 plus 36 is 61. So we got the same answer as here, doing it this way. I'm going to continue now. That's just AB. Now I want to find BC. So let me erase this. Let me change to green. Now we're going to do BC. So the length of BC is going to equal the square root of, and I have the formula here, so let's just go right to substituting in. We can reference the formula from the first example. So there it is set up. Now we just substitute. So we want x sub 2. We want x from the second point, which is -2, minus x from the first, which is 3, y from the second, -3, minus a -3 is +3. Simplifying that, we're going to get -2 minus 3 is -5 squared, plus -3 plus 3 is 0 squared, and I get BC equals the square root of 25, and that square root of 25 is 5, and there it is. And then finally the last one. So now I am finding the length of AC. We're using these 2 points. So now I take AC, I say the length of AC equals square root y2 or x2, look over here, x2, the second x is -2, minus the first x, which is -2, minus a negative is +2. Rather than writing minus -2, I'm just going to switch it to +2 here. And y2, -3, minus y1, which is 3, and that is going to cancel. So here, did I do that right? Yes. Okay, so here we're going to get, oh no, these two cancel, they're opposite. -2 plus 2 squared is 0. See, I was questioning that because if your y's cancel, then you have just a change in x. If your x is canceled, then you just have a change in y, and that's a horizontal and vertical line. All right, so -2 plus 2 is 0 squared, plus -3 minus 3 is -6 squared. So AC is going to equal the square root of 0 plus 36. So AC equals the square root of 36, and the square root of 36 is 6, which is right here. And I'm not going to go through this again, but all you would do then is add up all your sides. 6 plus 5 plus the square root of 61, which is an approximation of 7.81. And we would get the same answer of 18.81 units. Okay, example 3 wants us to find the area. I almost did it again, perimeter. It's asking for the area in the coordinate plane of this triangle DEF. Find the area with these 3 vertices. Okay, so again in Desmos, I'm going to switch to, and I'm going to plug in, switch to Desmos and put D 1.1 comma 3. So I come in here and I go 1 comma 3. Telephone. All right, what was the name of that? D. So I'm going to label it D. Okay, so there's D. E is 4, -3. Boom, 4, comma, -3, close parentheses, label E. Enter. And F is -4, -3. So -4, comma, -3. Label F. All right, so then when I zoom out so you can see this, there it is a triangle. So I'm going to show you how to do this now. This is a horizontal line at -3. That is a constant function, y equals -3. Notice how it went all the way across the screen off both ends. I don't want that, so I put space, and I put a bracket, and I put my left bound, which is -4. I use the less than symbol. I put an X. See how it cut it off right there? And then I do another less than symbol, and I want it to go all the way to 4, so I put 4. And I am done. There is my segment. Okay. The other ones aren't as easy. You've got to find the slope and the y-intercept. And so I'm just going to do that off screen so I don't bore you. Okay, so I use the 2 points to find the slope, and then I plug the slope in one of the points for x and y to find b, and I got y equals 6/5 x plus 9/5. It goes through f and d, and now I want to restrict the domain. So I'm going to do bracket, and I want my x to go from -4 to 1. So I'm going to put -4 here, -4 less than x less than 1. And there is my line segment going from F to D. And let me now do DE. Okay, so in doing that, I got the equation y equals -2x plus 5. It goes through D and E. And now I restrict the domain by doing bracket. And my domain starts at negative, or it starts at +1 and goes to 4. So 1 less than x less than 4. This is really cool. I like this. So there's my triangle. Okay, so the base F is at -4, E is at 4. So here's how we're going to do that. Find the area of a triangle. So the first thing we do is write a formula. A of a triangle, area of a triangle equals 1/2 the base times the height. So I need to know what my base is. I need to know what my height is, and I can find the area. So I already know what my base is. I could either count. So let me zoom in so I have all the values showing numbers. Zoom in, zoom in. There we go. So I'm at -4 and I want to go to +4. So I could just simply start here and go 1, 2, 3, 4, 5, 6, 7, 8 and say it's 8. But I'm going to do it the way we learned last chapter and say B, the base, equals the absolute value of one end, the difference of the two endpoints. So there it is, -4 minus +4, and therefore B equals the absolute value of -8, and the absolute value of -8 is 8. And that's how I'd show it using the distance or the ruler postulate. Okay. And so for H, we have to find the height. So let's go back here. And I'm just going to draw a line vertical at 1. So that's the line x equals 1. Okay, so there it is. But I want to restrict that. And I want to restrict the range on that. So I'm going to say I want y to go from, it is -3 to 3. So that would be -3 less than y less than 3. Okay, so there's the height of the triangle. And it goes from -3 to 3. So we could do that again and say h equals the absolute value of -3 minus 3. And h equals the absolute value of -6. So therefore h equals 6. And I'll put that there. So now we know what B is, we know what H is. Now we substitute our givens into our formula. So step 1, write the formula. Step 2, substitute the givens. So 1/2 and B is 8 and H is 6. And then A equals, now here's what I like to do myself. I like working with as small a number as possible when we're doing calculations. These are even, so a half will get rid of one of them. Well, what is half of 8? It's 4. So I can just cancel those out and get 4. And then 4 times 6 is 24. So the area of the triangle is 24 units squared. Okay? You always want to have that when you're naming it. And the reason for that is, here's how I should have written my equation. A equals 1/2 8 units times 6 units. If you write the word units into your formula as you're doing it and you multiply, then you're going to get units times units, which is units squared. Okie dokie. Okay, example 4 is modeling with mathematics. You are building a shed. And in this case, this pretty shed with the windows and the flower boxes, I'm going to change the name of this to a she shed. You are building a she shed in your backyard. That is a thing. The diagram shows the 4 vertices of the shed. Each unit in a coordinate plane represents 1 foot. So every little square in here is 1 square foot, 1 foot by 1 foot. Find the area of the floor of the shed. So what I'm going to do is I'm going to highlight this so you can see it better. Let's use, oh, I don't know, orange. Orange, you glad I picked orange? All right, so I'm going to start here and I'm going to draw up to here just so you can see this better. Okay, what we're talking about, these are this is the floor on the plans. Okay, and once we're done that, then now we can just jump right in and say, okay, well, what is it asking for? Highlighter, you're building a shed, find the area of the floor. And they're each 1 foot. All right, so we want the area. So that is a rectangle. Area of a rectangle is, step 1, write the formula. Area equals length times width. So I need to find a length. The length is going to be the absolute value. Let's call the length this way. So I'll call it L, and this is the width. The length, we want to look at, see how these are both 2? That's a horizontal line. The Y's don't change. So I want to focus on the X's. So the length is one end minus the other end point absolute value. So L is going to be the absolute value of 6. And therefore I found L to be 6 feet. The width is going to equal the absolute value of, okay, so now I'm going to focus on the Y's, 7 and 2. So the width is going to be 7 minus 2. And therefore the width is going to equal the absolute value of 5. And the width, therefore, is 5 feet. Now I'm going to take what I got and substitute into my equation. So I wrote a formula, substitute the givens, length, 6 feet, times width, 5 feet. 6 times 5 is 30. Feet times feet is feet squared. So the area of this she shed is 30 square feet. Okay, that brings us to the end of chapter 1.4. These are the exercises that I want my class to do. Have a good day.